Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing another example of a independent random variables and their sums problem in probability. Let x and y be independent continuous random variables with densities f of x is equal to 2 times e to the negative 2x if x is greater than or equal to 0 and 0 otherwise, and f of y is equal to e to the negative y if y is greater than or equal to 0 and 0 otherwise. Find the density function of f of z as z for z is equal to x plus y. This is another example of independent random variables and their sums. So let me write down the sum of independent random variables. We denote f of x plus y z is equal to the integral of negative infinity to infinity of f of x z minus y f of y dy. If x and y are independent continuous random variables with density function f of x and f of y respectively, then the density function of their sum x plus y is given by the convolution of this formula that I wrote down. This is the sum of independent random variables. So in this problem, we're trying to find the density function of f of z for z is equal to x plus y. So in other words, let me write down f of z to z is equal to the integral of 0 to infinity of f of x z minus y of f of y dy. This could be also written as f of z is equal to the integral of 0 to z of f of x z minus y f of y dy. But f of x z minus y is equal to 0 when z minus y is less than 0, or in other words, y is greater than 0. So let me just plug in the numbers. So we have f of z is equal to the integral of 0 to z of 2e to the negative 2 z minus y. I'm just replacing that into x. E to the negative y, which is f of y dy. And this could also be simplified to integral 0 to z of 2e to the negative 2z plus 2 plus 2y minus y dy. Simplifying more, we get the integral of 0 to z of 2e to the negative 2z plus y dy. Now let me just take out, to make this easier, I would like to factor out a 2 to the e to the negative 2z. Of the integral of 0 to z of e to the y, that's what's left, dy. Now I can just integrate e to the y, it makes it easier. Well, e to the y is just e to the y, and then plugging in f of z, get e to the z, it's just e to the z. And also we get f of 0 is just e to the 0, well that's just 1. So we take these two, it's e to the z minus 1 times whatever's left. It's 2e to the negative 2z. So in other words, this would be 2e to the negative 2z times ez minus 1. So we can write this as the density function f of zz is equal to 2 times e to the 2z ez minus 1 if z is greater than or equal to 0, and 0 otherwise. And this is another example of an independent random variables and their sums problem in probability.